All right, 3.2 is all about finding the exponent laws. So for this video, I'm just going to explain how we get the exponent laws we do and where they come from. And then if you want practice with exponent laws, that's going to be the next video. So the first exponent laws we start with is where we've seen a number, say 2 to the exponent 3 times 2 to the exponent 4. The important piece of this is the bases are the same. And when we do that and we actually expand it, we put it in something called expanded or exponential form. Pretty sure I didn't spell that right, but that's okay. We're going to break this down. So 2 to the exponent 3 is 2 times 2 times 2. And 2 to the exponent 4 is 2 times 2 times 2 times 2. And so in total, we have 7 2's, or 2 to the exponent 7. And what we noticed is we're actually adding the exponents to get the new exponent. So the rule we came up with is a to the exponent m times a to the exponent n is going to give us am plus n. So no matter what this number is, they have to be the same. If we're multiplying them by each other, we add the exponents, and that would be our answer. The next rule, we'll label that rule number 1. Rule number 2, we see in the form a to the m to the exponent n is a m times n. And so if we do an example, 2 to the exponent 3 in brackets to the 5, let's choose a smaller number actually, so it's a bit easier. So that means we have 2 to the exponent 3 to the exponent 2. So we have 2 3 times, so 2 times 2 times 2. So that's 2 3 times, but we have that twice. So 2 times 2 times 2. Okay, so we have this whole thing 2 times. So in total, we have 6 2's. And if you notice, 3 times 2 is going to give us 2 to the 6. So that rule works as well. Our third rule is a to the m divided by a to the n. And all these rules, the labels of them might be different from our notes, and that's okay. And we say if we're dividing numbers of the same base with exponents, we can subtract those exponents. So 2 to the exponent 5 over 2 to the exponent 3. Well, if I break it down, I have 5 2's on top. I'm going to use the dots for multiplication here, so it's a little bit easier. And I have 3 2's on the bottom. And then we talked about what happens when I divide 2 divided by 2. We get 1. 2 divided by 2, we get 1. 2 divided by 2, we get 1. So that doesn't really change, right? 1 times 1 times 1 is just 1. And 1 times 2 times 2. So really, all we're left with is 2 2's on top. So we're left with 2 squared. And so if we did 2, 5 minus 3, we would get 2 squared, which is the same thing. That rule works. And our fourth rule is for any questions where we have 2 different things inside the brackets to an exponent, and they can be divided by each other, they can be multiplied by each other. Okay, the rule is the same. You bring that exponent, to each value inside those brackets. So a to the m and b to the m, or a to the m divided by b to the m. So the exponent applies to all of them. And if we did an example of that, 2 times 3 to the exponent 2, that means I have 2 times 3 twice. 2 times 3, 2 times 3, that means we have 2 2's, and we have 2 3's. All right, which applies the same thing to our rule of bringing them all in. Our fifth rule is we have a to the exponent 0 is going to equal 1. And what that means is, let's say we have 2 to the exponent 3 divided by 2 to the exponent 3. If I actually expand this, 2 times 2 times 2 over 2 times 2 times 2, 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. 1 times 1 times 1 equals 1. So all we're left with is actually 1 here. But based on the previous rule, we learned that if we were dividing numbers of the same base, we subtract their exponents. So 3 minus 3, which gives me 2 to the 0. And we just figured out it gives us 1. And that is our proof. And then finally, we did look at exponents with bases with negative exponents, and we said the simple form of them is 1 over them in a positive light. And if we did an example, 2 to the exponent, let's say 4, and 2 to the exponent 2, when I break that down, 2 times 2 times, sorry, I'm going to switch them around actually. 2 to the exponent 2 over 2 to the exponent 4. 2 times 2, and on the bottom we have 2 times 2 times 2 times 2. When we cancel, we are left with 2 2's on the bottom, which means there's only 1 left on top. And if we were to use our rule where we're dividing the same bases, 2 minus 4 is 2 to the negative 2. And we've noticed that we proved that these mean the exact same thing, and that's why we're able to write it that way.